Good to see you again. I remember just a week before you were awarded the Fields Medal, I was examining your student, and he very cheekily put at the end of his presentation, "Good luck, Maryna."
Oh, I see.
Those words came true, and a week later you were awarded the Fields Medal. So, congratulations!
Thank you.
It's a great honor to have you. And so this is BMUCO of a student-run NGO, and I'm one of the scientific advisors. And we're actually physically in the London Institute for Mathematical Sciences, which is, this room is one of the rooms that Michael Faraday lived in. So we have the set that Faraday lived in. So it's a great honor for you to speak in such a historical space. So let me just kick off with a very, very simple question. I'm sure that everyone in the audience is waiting for. Could you explain in 2 minutes to a non-mathematical audience what is the subject for which that you were awarded the Fields Medal this year?
Yes, I was awarded the Fields Medal for the solution of the sphere packing problem in dimensions 8 and 24. And so maybe we can start with what is a sphere packing problem. And maybe first let me explain it to you in dimension 3. So imagine that you have a Faraday room and you have an infinite supply of tennis balls, or maybe even better, like hard, I don't know, billiard balls, so that they are like perfectly round and not they cannot squeeze them, they are just hard. And then you try to put as many billiard balls as you can into this room. And then because room is big and balls are small, so you will understand that what happens, the boundaries near the walls, near the ceiling is not that important. The all interesting thing actually happens in the bulk. And this what will have the main impact on the answer. And so maybe you would like, instead of computing the exact number of balls you can put into your room, you would like to compute the average density of balls. So how many balls per volume do you have? Or maybe what is more common to say, which portion of the total volume of the room is covered by balls. And so in dimension, so this becomes a and of course, to look at all this mathematically, what mathematicians would do, they would just say that we are not packing balls in a room, we are packing them in all Euclidean space, and we want to fill all the space with these balls, and we care about the density, the average density. And so this is a geometric optimization problem. And as you can see, this geometric optimization problem with infinitely many degrees of freedom, because each ball can somehow move on its own. So it seems to be a very complicated question. And actually in dimension 3, indeed it is. And it took mathematicians many centuries to solve this problem. So it was known for almost 300 years as the Kepler's conjecture. And then it was solved by Thomas Hales at the end of 20th century. And it was one of the first computer-assisted proofs of an important mathematical result. And so what my work is about solving a similar analogous problem, only not in dimension 3, but in dimensions 8 and 24. And so here we can go into asking what are higher dimensions, what are balls in higher dimensions, what are optimal solutions in higher dimensions. But okay, but maybe here I will stop. I took more than 2 minutes, so maybe I will let students ask more questions.
Well, no, thank you very much. You know, you certainly have some BMCU would like to have some much more personal questions about this your Fields Medal work.
Yeah, hi Mariana, and
hello.
UI, and I'm founder at BMCU. We've been working in this organization since 2017, and so I'd like to have one questions, and that is, I think it's simple. How do you feel when you first know that you won Fields Medal, the greatest prize in mathematics, and you were the second woman to win the Nobel Fields Medal? What was the feeling?
Yes, I felt very honored because so so few mathematicians get this award, and yeah, so of course it was a good feelings. Will not lie here.
That's perfect. So there is another one more questions. And so what is the significant challenges that you faced during your career? Because I'm myself a physics student, and we like to be in academia in future. A lot of people who are joining right now are trying to go to academia, and maybe some in industry. So what do you think your significant challenge were while you were in the career of being a mathematician?
Yeah, so there are maybe, like academic career, it's a maze, and yeah, it's somehow not given that you will find way to the next level. So for me, like for me personally, maybe a big challenge was balancing between my personal life and work, because the work of a mathematician also requires a lot of moving around, changing cities, changing universities, and yeah, so this is somehow not easy to combine with having stable human relationships. And this was the part was difficult for me. And also sometimes I feel that maybe that's, I don't know, something which is unnecessary. So for example, if you want to be a physicist, you have to work hard or work a lot, and this is clear that this is necessary. And at the same time, I often felt that the fact that I have to move to a new city every 2-3 years, it's not so much necessary, just if you look at from this at the point of view, I don't know, from mathematics that I do. So
that's perfect. I think it's really great.
If I could just follow up with a quick question.
Please.
Did you at any point in your life ever doubt that you were going to pursue mathematics? Was it something that you always knew as a child?
Yes, open mathematics is something I enjoyed a lot, but I think as a child I did not know that becoming a professional mathematician it's a real thing. So of course I knew that there are math teachers at school and that there are professors at the university, but maybe it was quite late in life when I realized, for example, that mathematical research exists, and I think as many people. For many people, it's actually still discovering that there are some things in mathematics that are not known yet. So, like we know the table of multiplication, we know how to multiply very big numbers. So what else? What else can we do? So yeah, and of course, like when different points of my life, I thought about maybe going to industry, maybe doing some creative things. But yeah, but still, probably mathematics was the most interesting activity I ever discovered for myself. So I am happy that I stayed.
No, for the world, we're happy too. Did you have a particular, mentor or hero figure who truly inspired you to do mathematics?
Yeah, I think actually I think I was extremely lucky, and I had many inspiring teachers in my life, starting from my school. So I think even my first math teacher in a public, like how it's called in Russian, it's called like average school. So which is probably a terrible name, but okay, maybe middle school is probably a better translation. So she was like a very strict, very tough woman, but somehow for me, I think she was very enthusiastic about mathematics, and this already was inspiring. And then when I studied at high school, a school which was specialized in physics and mathematics, my math teacher, he was a person who actually was a professional mathematician for some part of his life, and then went to teaching in a high school. So he was also he had this very, I would say, somehow broad view on mathematics, and could always suggest things far beyond what we normally learn at school. And similar experience I had at the university with my teachers, my mentors, people who actually introduced me to doing research. Like Igor Shevchuk, who was my professor at Kyiv University, also Sergei Evsienko, who was my algebra professor. So Yeah, so and I can of course continue. I think my PhD advisor Don Zagier is certainly amazing person, and just meeting him, it's already like a great adventure in life. So yeah,
he's a great poet.
And that's why I do believe that, you know, this like ancient idea that knowledge, it does not go from like it does not live in books or on this clay tableaus or in computers. Knowledge lives in human heart, and it comes from human to human, so from person to person. So
that's great. Yeah, we'll turn over to you for your.
Hi, so I'm Rajarshi and I lead the National Science Research Team at BMUCL. So my first question would be, has your personal life ever affected your work in mathematics? And do you think like the underrepresentation of women in maths or in general in STEM has ever made you, you know, like feel like less motivated to work, and how did you overcome it?
Yes, so as I just told you, so I think that actually combining personal life and career in science is not easy, and mainly it's somehow for this, to me it seems like for this what kind of an external reasons, and so here I don't actually I think for maybe for men it's probably also almost as difficult as for women, but the period when, for example, my son was young, but at the same time, both myself and my husband, we don't have a permanent job yet. It was a difficult period, and from my experience, actually, many of my friends who started, who were, for example, PhD students, like women, that this is actually this period between PhD and postdoc when women decide that for like having a family and also traveling around the world is somehow not really compatible. So, but here I don't have any, so to say, statistical data. This claim is not supported by any kind of studies. It's just based on cases I know and people I know. But in my experience, this is time when many women actually decide, okay, so better I do something else because this is not so feasible. And
yeah. So, and my second question is, like, are there any long-term projects you're working on, like, which you hope to solve, like, you know, in a long-term, like, do you think you might be able to solve, or just, you know, you're interested to solve in a longer time?
Yeah, of course, always there are problems. In principle, I do continue working on this geometric optimization problems, and here there are many open questions that I hope to see solved. And I'm not sure if I will solve it or somebody else, but then things like sphere packing in dimension 4, beautiful problem, and I really hope that we will see how it will be solved in I don't know, several years. But then there are maybe like some more philosophical questions, and for example, what like this very core questions of sphere packing and also coding theories, like for example, to know more about packings in very high dimensions. I think this is still a pretty mysterious question, and I don't think we will ever have the ultimate answer to that, but there are many things where we can improve on. So yeah, and also I believe that maybe the most interesting scientific questions are questions that we don't know yet how to formulate. So of course, it's very often, especially pure math, is driven by this kind of challenges, like Hilbert problems, Clay problems. This all like a hypothesis with big names where it's a clear goal and people are essentially competing to solve them. But I also think that a lot of great research comes just from the places we did not expect. So we also should stay open-minded and hope for like discovering new phenomena. And here, of course, the thing is that if you want to discover new phenomena, then you cannot set up your mind what this new phenomena would be.
Maybe we can take audience questions.
Yeah. From James who would like to ask some questions.
Yeah.
So actually, we have behind us our first Arnold and Landau fellows, Professor Shkredov and Dr. Osherov. And because of our program that we're now, recruiting Russian and Ukrainian and Belarusian mathematicians at the London Institute. So we have our first Arnold and first Landau fellows behind us. If you want to ask any questions.
Hello, Maryna. Thank you for your interview. What is your current project?
Sorry?
What is your current project?
Just maybe, okay, maybe I don't want to open all my cards, but yeah, but there's like problems in in geometric optimization. So,
are you working on any of the clay problems?
No.
It's interesting that the sphere packing problem, which I love, was not one of the clay problems.
Yeah, but I think, this lists, they're often a bit, I don't know, I can say arbitrary, but I think not all great problems are in those lists. So it's, so I know, maybe according to the clay list, maybe, I don't know, maybe one day I will eat a lot of ice cream and solve like the BSD conjecture, but that's not
I guess that one is sort of the closest to your thing, right? The BSD, because
yeah, at least it's closer to the kind of education I got, but yeah. At the same time, should confess I don't have good ideas yet.
Well, certainly if you're working on BSD, the best of luck to you, because that is a beautiful problem.
Yeah, it's beautiful. No, I should confess. No, I'm not seriously working on them, but it's kind of a problems I find very beautiful. And actually, once I don't know, there was I don't remember. There was a meeting of mathematicians where mathematicians voted on what they think would be the next problem of this clay list solved, and somehow BSD conjecture got the least number of votes, which made me a bit upset. Probably it means that number of people who are working on it is small. So maybe if you want to solve a problem of the list and want the list competition, then maybe that's right.
Let's see.
Right thing to look at.
I guess it's also one of the more technical ones in terms of the
yeah, I don't know. I mean, I think the Young Mills, Navier talks are also quite complicated.
Yeah, we also have a few questions.
We have questions online, so we have got loads of questions.
Yeah.
Do you have any questions? Well, you can ask Maryna while we look for these online questions.
Yeah, just check this out.
So let's see. How do I have?
So these are the ones that.
So this is. Oh, here's a good one. How do you keep yourself motivated to work on a problem for years? And how do you know when it is time to give up?
I think there is no universal recipe here how to know when to give up. I think it's maybe the right thing is like never to give up. It's maybe because maybe sometimes it's good to stop and to switch something to something else, but yeah. Yeah, so there are many different types of motivation. One of them is just genuine interest in what you do. There is also element of competition. Maybe, I don't know, if you've thought of a problem and you know that somebody else also starts working on it, then it's like it becomes a bit like, okay, I have to be first. And yeah, and of course, what is probably also important to keep motivation is that even though sometimes you don't have like complete success, it's important also to make some small steps and understand new things about the problem you are working on. So it often, of course, somehow when you're making those small steps, and it's often not clear whether they are useful to solve the complete problem. But I think this also what somehow if the small steps are somehow nice mathematics on their own, then this also gives motivation to continue and to keep working. And I think also very important is to have some people who work alongside with you so collaborators or people with whom it's possible to discuss this problem.
That's perfect. And do you, yes. So there is one problem which says, what attracted you to the field of spare packing problem?
Yes, so I worked in, because somehow I first got attracted to this optimization combinatorial and geometric problems, then started learning what exists in a field, going to conferences, workshops, and eventually learned about this problem. So it was somehow when I learned about work of Henry Kohn and Noam Elkis on linear programming bounds for sphere packing. I already worked on geometric optimization problems a little bit, so it was somehow, in many senses, a natural continuation of what I was doing before. So.
And there is one more question, and which might not be directly related to you, but a lot of people who are joining right now are from developing nations. So they are asking, how can a researcher in a developing country overcome the obstacle to conduct mathematical research?
Sorry, can you repeat again?
Oh, yeah. So how can a researcher in a developing country, developing world communities, overcome the obstacle to conducting mathematical research? A lot of problems comes with financials and a lot of other problems. So how do you keep, I think, a way of making you continuously motivated, even the things are not in your favor? And particularly that happens with a lot of students from developing nations.
Yes, I think maybe it's not an easy question. And what happened to me eventually that I moved to Germany. So, and of course I realized that this kind of solution, it cannot work for everyone and should not work for everyone, because it's, I do believe one of my core beliefs is that like talent for anything, in particular for doing science, is distributed around the world, around nations, around genders, and also maybe it's not. I think that science, it's an important, or scientific community, it's an important part of every healthy society. And even though in developing countries, unfortunately, very open society itself does not value science, does not understand why should we spend resources on this kind of useless things. But I think in the long run, actually, good science and good education, they do a lot of a difference in the future of a particular country. And yeah, so here I don't have any kind of magic advice, but like in my own country, I meet many young people who are extremely enthusiastic, who want to study. And what makes me happy is I meet many people who do not want to leave Ukraine, who want to stay in Ukraine and teach and conduct their research in a country where they are. And I think this, after all, this is a big work for young scientists who should not give up and who should search for possibilities to study, to fund their research. A lot of work for older people like me to somehow to convince, maybe even I get a possibility to convince politicians, to convince people of business, to convince just general public that funding research is indeed a good cause, and that it has to be done. And so what often also makes me happy is the story when young people get an opportunity to go abroad to get good education, but then are willing to come back to their own country. And I think this often, like right now, I see this happens a lot for students from India, for students from China. And after all, I think this is a good tendency. So
yeah, I think that's a really good answer. That's really great.
Do you how do you balance your time between your research students and undergraduate teaching and your own, private deep dive research yourself? How does?
I don't know. Not great. So if you want a time management advice, I may be the worst person to ask about that. So
Do you take a lot of? I mean, I know you're a master's student that I was external examiner to. But do you have a lot of PhD students? A lot of what is your style there?
I don't have too much, too many. I think so right now I have 2 PhD students, and which is not that much. And I think 3 maybe it's right now for me it's my limit, and I think it's maybe better to do less. But because especially in the case of PhD students, I think mismanaging a student is actually somehow high price for. First of all, for the student, because these are students, they sacrifice maybe 3-4 years of their probably most valuable time in life, and it's really important that this time is well spent, and that they get good. Hello, can you hear me?
Yeah. No, it's all good. Yeah.
I think that the picture got frozen. So that's why I don't try to take too many students.
No, we can hear you fine. Yeah. Somehow.
But I think.
Yeah.
Oh, okay.
Okay.
Yes. So. Then no, I don't have general rule here. I also because I think writing a PhD, it's a very personalized process, and all people are different. And yeah.
Do you have undergraduate teaching? Do you
yes. Every year I do 1 course, and then for the first year students. So this year I was teaching discrete mathematics, and we'll start in spring.
Wow.
But actually I don't know. Somehow undergraduate students, it's sometimes I find that undergraduate students is actually more fun than teaching master students. Because I think, I don't know, my feeling sometimes is that undergraduate students, they're still somehow so fresh, they're open to everything, and after 5 years at the university, very often students are already a bit tired and maybe need to somehow, they are like before this coming to the next stage in their life. And usually I do have a lot of fun with undergraduate students, and also I think I teach course which I consider it as kind of a more relaxing, fun course. It's discrete mathematics. So I think that maybe students should struggle a lot in analysis and a little like struggle in algebra, but discrete mathematics, it's more or less a fun course where they can relax a little bit.
That's interesting. You mentioned that, there's this sense of freshness and curiosity decays over time. I would imagine that for the ones that don't decay, they continue to be professional mathematicians. Or do you think?
Yeah. I think there is a lot of truth in this. Yes. Because I think after all, being scientists, it's a bit like staying a child forever, right?
Yes, that's right. The curiosity is.
Yes. I think that's really a driver behind scientific research.
But that's interesting because one of the founding principles of the London Institute and also for BMUCO is curiosity-driven life. Somehow it's quite sad to see that in general, even among academics, that sense of curiosity decays. So can you give some advice on how to continually to ignite that fire, even for professional mathematicians?
So I don't know maybe it's not easy to say. It's maybe some kind of self-care is important, certainly, because I think many students, they certainly try. I don't know, like once a student came to me and asked me about advice. So like, what should I do? What kind of books should I read? I spend every night at the library. I read all the books. So what should I do? And I told him, go and sleep. And he was very unhappy with my answer. He was like, okay, that's for whinies, that's for weak weak people. Give me real advice. And I tell them, no, you should. It's my very real advice here.
That's really interesting. So as you were developing as a mathematician, were you of the type that completely suffered and didn't sleep, or it looks like you took care of yourself, which I think is very important. Is that true?
Yeah, but I think at some point we all like learn it some kind of hard way, right? So you. No. But I think actually when. Yeah, in terms of my, I think when I was actually a master student, PhD student, I also had this idea that if I work at night, it would be somehow something good could come out of it. And usually nothing good actually came out of of that sessions. And then maybe my son is who kind of changed my attitude to health and sleep. And then I was actually forced to switch to day life, to work during the day, work at night, and I think actually that thing works. So it's he was a person who disciplined me.
It's kind of interesting. We have visiting here my old undergraduate mentor, Professor Alexander Mikhail, who is also a great Russian mathematical physicist. His advice to me when I was an undergraduate is that you should suffer and suffer and suffer until you're purified. So I think the combination of his advice and your advice is the is the perfect combination.
Yeah, but I mean, maybe yes.
You had another comment.
No, I think that's the every question. I think we've pretty much finished all the questions. If anybody has a question, you can raise the question for the final questions if anybody has. And anybody in the online also.
If they could chat up any
if anybody would like to post the questions. But I think we are already past the time.
We're already fine. We've taken up so much of your time.
Yeah, we already taken up your time. And
so thank you. It was a pleasure talking to you, and
thank you.
I wish you.
Importantly, I mean, when the dust settled, I know you're super busy right now with so many invitations. But when the dust settles, I hope you could come and visit us here physically in Michael Faraday.
Would be, that would be great. So maybe for the several, for foreseeable future, it would be difficult, but at some point would be great to visit.
Because you have many of our old friends here. Like I think Sasha Kusiek is going to join us shortly. Our next honored fellow in mathematics. So we're eagerly awaiting for you physically to visit us.
Yes, of course, that would be great. Yeah, so thank you a lot for the invitation, and hopefully see you soon. Goodbye.
Yeah,
thank you very much.
Thank you.
Thank you.
We'll call the meeting then.
Yeah. Yep.
Thank you for everyone attending the meeting, and thank you for Professor for inspiring us.
Absolutely. Thank you very much.